I'm Peter Bailey Wells. I'm from Corporate Carlisle High School, Corporate Carlisle Weather Services, and we have here, this is Brian, and we have here a poster about a CO2 study that we've done in a public high school, and really, you know, the work that's involved and the potential for expansion on that project. We worked on, over the course of a day, measuring CO2 in a classroom where 5 out of the 7 periods there were 20 or more people in the classroom. Two of the periods of the day there were far less. There were no classes going on, and we measured the CO2 every 5 seconds over the course of the 8-hour school day. And what we found was that indoor CO2 levels are quite higher in this classroom than is sort of legally recommended. Massachusetts Department of Health states that 800 parts per million is the legal guideline maximum for indoor CO2 level quality, and we exceeded that considerably. Our max over the course of the day was 1382 parts per million, and it never got below 800 parts per million during the course of the actual school day. You want to go ahead?
I think kind of what we can take away from this project as the results compiled is that, number one, our school isn't really set up to deal with the problems that CO2, the high concentrations of CO2 may pose, because as we did more research about what CO2 actually does, we discovered that it can cause drowsiness in students, which obviously can affect their performance on tests, exams, their learning. So one thing that we had to take into consideration is that we're from Massachusetts, and this study was done on a cold day in November, so we couldn't exactly just open up the windows to release some of the CO2. This is a problem that we have from when it starts getting cold, so October, until when it gets warmer again, which is sometime in February. So for a good half of the year, the students are exposed to high concentrations of CO2. So I think moving forward, we should use studies like this in our school, and hopefully we can spread this to other schools around us to see if the amount of CO2, the concentrations of CO2 is an acceptable level below the 800 ppm that Peter mentioned.
And do y'all have any plans to further this research or any other experiments y'all like to do?
We've been talking with Earth Networks, who we featured on our poster, about potentially building a switch into the school that we could switch from outdoor CO2 levels to indoor CO2 levels. So we could compare what's going on outside between what's going on inside. We've even had talks of building in other classrooms into the network, such as potentially a biology classroom, which has a lot more plants. So we could figure out, do plants, which perform cellular respiration, right? Does their CO2 intake affect the parts per million, the concentration?
And what was your motivation for doing this project? Was it assigned to you, or did you just kind of come up with this on your own? How did that work out?
I would say we kind of stumbled into it, because at the last conference in New Orleans, we ended up with contacts at both Earth Networks and WeatherBug, and at LICOR, which provided us with the sensor and the gas analyzer, actually. And they asked us to beta test their product for us, and we figured this would be the most efficient way to do it. And the results that we got were pretty interesting, and I would definitely say that this is something that other students should take a look into, because it was pretty easy to do, even from, I'm a high schooler, I don't have a lot of training in this field, so I think it was easy for me, and I think that it's something that anyone can do.
And as a high schooler doing this research, what did you kind of learn about yourself, about research you might want to do in the future, maybe when you get into college, or I know graduate degree is way in the future and you're probably not even thinking about that right now, but what did you kind of learn about yourself through this project?
One thing that I kind of realized is that variables are a really important part of the experiment, is that when we do labs in school, we control the variables very easily, because it's a defined system that the teacher sets up for you, or you set up yourself. But in this, it was an experiment about real life and what's going on in the worlds of people every single day. And you can't just tell people that, oh, today you can't bring in a soda can because that might release CO2. I don't know, but you can't necessarily control the variables of the world around you. This is kind of my first study into practical science and how it affects everyday human life.
Okay, cool. And what about you, Peter? What did you learn about yourself?
I think Brian's definitely right. Talk about variables, and in particular the note taking, or not note taking, but the recording of all the variables when you're considering presentation of the project. Because when you come up with your own experiment, when you design your own experiment, you have to account for everything. You know, if you lose something, if you miss a specific part of it, you don't get the full picture. And I think there's a few things about our project that we might like to specify more and haven't. And so that's something to take away from it in the future. Covering all the bases, and once you do that, it's much easier to expand the project. It's much easier to make it more complicated. So yeah, it's been really interesting as a baseline, kind of not for school credit, totally self-motivated, which is, in my opinion, much more interesting and much more engaging to do than one where all you're shooting for is an A.
Right. Well, thank you guys both, and good luck in college.
All right, thank you very much.